Hey guys, welcome back to Stat and Research 2. This week and next week, we're going to continue our discussion of multiple linear regression by talking about variable selection, checking our assumptions of multiple linear regression, talking about outliers, and then talking about multicollinearity. These 4 lessons are going to be wrapped up into just one homework assignment, so check Canvas for that due date. Also, as the semester's starting to come to a close, we are going to have a final. To help you guys feel prepared for the final, I'm going to be making a practice midterm, which can also be viewed as another extra credit opportunity. Other than that, I don't have any big other class announcements. So let's get started on lesson 14A which is motivating variable selection. So in lesson 14, we're going to continue our discussion of multiple linear regression. Specifically, this entire lesson will be focused on choosing which variables are going to be in our multiple linear regression. In this specific lesson 14A video, we're going to introduce 2 terms called overfitting and underfitting and do just some motivation on why and what variable selection is. So let's get started. In simple linear regression, we didn't have to worry about the idea of overfitting and underfitting because we only had one predictor variable. But in multiple linear regression, our goal is to build a model, right? And we want this model to be able to best represent the relationship between our variables and our response. Well, what can happen is one thing is that we could overfit our model. That means we're going to put too many predictors in the model where only some of them are where some of them aren't explaining a lot of the variability. Another issue we could have is if we underfit our model. So we have not enough predictors to explain the variability in the of our data using the model. A typical quote you'll hear by George Box is all models are wrong, but some models are useful. And the idea here is that we will never be able to create a perfect model because we'll either be overfitting or underfitting our data. And our goal for trying to choose variables, which ones go and either do or do not go in the model, is trying to find the best subset. So we're trying to balance this idea of overfitting and underfitting to kind of find the medium ground. Okay, so let's look at an example to see if we can try and motivate this even more. So in lesson 14, we're going to have the cement example, where a company wants to find which chemicals contribute to the heat, the Y, in their products. So we have 4 chemicals, and I'm not going to try and pronounce those words to save myself some embarrassment, but we have these 4 chemicals, and we want to understand which of these 4 should be in the model or shouldn't be in the model to best help us explain our why with hopefully not overfitting or underfitting the data. So a couple ways we can do that is through variable selection procedures. Now, in this class, we're only going to talk about a small set of variable selection procedures. There are a multitude of other ways, but learning about these 2 topics should hopefully give you a foundation. So if you wanted to do more in your research or do a different approach, you at least have the basis and understanding of what variable selection is. So in lesson 14B, we're going to talk about these more classical step selection procedures, forward, backward, stepwise, sometimes also called mixed selection approaches. These approaches are more classical or historical because they don't require as much computing power as the subsets, best all subsets procedures had. Back 20 years ago, computation and computers weren't what they were today. And so these approaches were probably the best solution for that limitation. In 14C, we're going to look at the best subset procedures, where we're going to look at all possible regressions using these 2 statistics, and then briefly bring in AIC and BIC.